These are your 6-4 video notes. Today we're just going to talk more about solutions in zeros and how to find zeros. So far we've dealt with zeros, mainly it's been by factoring that we found our zeros, or we gave you zeros and asked you maybe to create factors. But we have situations where we have polynomials that don't factor, and so we have to have a method to take care of that, and that's what we're going to talk about today. So we'll kind of blend in some stuff from earlier in the chapter, at the same time introducing the new ideas to you guys. So let's get going. So let's just do a little recap review here of finding zeros by factoring. So let's start with something, and not just like your basic two sets of parentheses factoring. Let's go to some of the other factoring that we did, like when you can take out something from each term. So for example, here I can take out an x, and then these three, yes, those can be factored kind of in our traditional sense where we ask ourselves, what are the factors of 8 that give you a 2? Well, it's 4 and 2. We should all be good at that by now. And so we have x minus 4x plus 2. And for the reason this has got to be -2, -4, +2 is because that's a negative middle term, so we need it to be negative. And then our zeros would come from what happens when we set each of these equal to 0 and solve. So there's a list of zeros, so factors compared to zeros. Now down here I added a third one, solutions, so we can kind of do another round of comparison, which we talked about earlier in chapter 6. So one of our other new methods was factoring by grouping, where you group the first two and the second two, and you look for what's in common just in pairs. So in pairs, here I would take out between x squared and x to the third, I would take out x squared. And then when I get that first factor showing up, then what I expect to happen when I'm doing factoring by grouping is it would show up in the other pair. So really, once you get this, it's more or less like, how do I produce this by using these two? Well, if I take a 4, divide a 4 out of each 12 and 4, pull a 4 out, you'd have 3 and 1. So I created the like factor. Then how we treat this is we take our common factor, which is this one, and we pull it out, because remember, that's really just something that's something that's the same in both spots, so we can take that thing out. And then we have kind of like what I call our what's left factor. Now going to solutions. So solutions, we actually literally on the paper set them equal to 0, and we solve. This one produces something a little bit different. We haven't talked about complex numbers for a while, but we have done this kind of solving. We have worked with I. So when you solve this equation, you take the square root of a negative plus and minus 2i. So solutions. So we're getting some real and we're getting some complex. And then take away the x and just do a list, and there's our zeros. So again, kind of always doing that comparison of factors to solutions to zeros. Okay, so these are ones where we could factor and find our answer. Now we're going to lead into the idea of where we can't factor, but we can still try to find our zeros. So I'm going to show you some new methods. Now let's say you were just testing, like you wanted to know, like because you didn't have an idea, like are these zeros or not? Where are the zeros? We do know how many there are. First of all, remember that there should be as many zeros as there is degree or exponent, because we know that'd be like 4 zeros or 4 factors or 4 x-intercepts. Some may be real, some may not, but we still know there should be at least 4. And then here we're just asking, let's just randomly kind of check stuff. So let's just try the numbers 1 and -1. Now this would be old school method you guys are used to, which is called basically direct substitution. So if I want to evaluate at 1, like I want to check 1, just plug it in. What I'd be looking for is, did I get a 0? Remember, that's the idea of the 0. When you put it back into the function, or you put it back into a factor, it produces 0. So if I plug in the 1s and check it out, turns out those numbers added up give me a 0. So that's a yes. So my 0 is 1. Remember, if you kind of work it sort of backwards, my solution would be x equals 1, and my factor that would have come from that would have been x minus 1. So there's actually one of my factors that I can go backwards in order from my 0. Now, just kind of, again, randomly checking numbers, so we're going to just try positive and -1, just check it out. So we'll put in -1. That also produces a 0. So what that means, again, is my 0, another 0 would be -1. As a solution, it would be x equals -1, and as a factor, it would have been x plus 1. Now, again, think of us going this direction like we did in the previous slide. So if I started here, set equal to 0 and solve, I get this, then take away my x equals, list it out as a number, and there's my 0. So what that means is that x plus 1 and x minus 1 are 2 of the 4 factors. Again, we know there are 4 zeros, which means we know there should be 4 factors, and there we just happen to find 2 of them. So the idea of you getting a 0 is important. Now, here's the thing. This kind of testing can be pretty time-consuming, especially when the number you're testing is not a 1. Let's say it's a 2 or it's a 3. Well, then all of a sudden it's a lot of calculation, it's a lot of work. So we want an alternative method to figure out this, and that's what we're going to talk about next, is what's the alternative. So we're going to introduce a new method, a new concept called synthetic division, or synthetic substitution, you can call it both. And basically what we're doing is we're going to figure out, we're going to just, again, give you some factors first and then solve them so we can kind of turn them into a zero and then test. Is that zero actually a factor? Now the way we would know it would be a factor would be that, like if we plugged in the number itself into the function, we evaluated and we got a zero, but we got an alternative way to do that called synthetic division. So I'm going to show you how that works and I'll explain what it is that it does for you. So synthetic division has a unique setup. You have to, first of all, in this case we're going to do it as division and talk about what happens when you get a zero in the problem. I'll explain in a second what happens when you prove it's a zero, I should say, which then shows you that it's a factor. But for now we're saying go ahead and divide these two. Well, to do synthetic division, what we do is we first of all take the zero of the divisor. So what would you plug in right there that would cause this to become zero, which is pretty easy, you just solve it. We kind of have this little structure. You guys have to use kind of drawing this little structure, this little skeleton here that kind of fits in all of our stuff. So we do our -1 because that's the zero from that factor or from that divisor, what I'm dividing by. Then we list out the coefficients from the original function, which are these numbers that sit out in front right here. Now here's where it's the first time you guys have done this, so you got to kind of hang tough for a minute while we do the process, but once you get good at it, it's really easy. The first number actually gets dropped down. And then we go through a series of multiplications and additions. So we multiply on the diagonal and we add the columns. So -1 times 1, -1, and then we add that column down and get a 0. Then we just keep going. -1 times 0 is 0. We add that column down, we get -7. -1 times -7 is 7. We add that column down, we get 6. And -1 times 6 is -6. We add that column, we get 0. Now, to the question, is that a factor? Well, we just did this. What we did there by using synthetic division is prove the same thing we saw on the first slide, which was instead of me plugging this -1 in here, 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 and adding up all the numbers, I can do synthetic division and prove it by getting a 0 remainder. This is what's called your remainder. So what's left over when you've done your division? Nothing. And you guys would know that from numbers, right? If you go back to like your middle school days, if a number went into another number evenly, that's how you used to say it with numbers, right? You'd have a remainder of 0. That meant it went in there evenly. So it's a similar idea in a basic sense. Okay, well, let's try +1 also. So again, is this a factor? So let's do it as division. So we're starting out as saying, hey, it's a division problem. We're also trying to roll it all into the idea that can I prove that this factor, this 0, is actually the 0, one of the zeros. So let's go ahead and try it again. Now, if you're going to do this with one after the other, it's best to not go back to the original set of numbers. It's best to actually grab this set. At this point, we've basically factored this out, or we've taken it out of the original function. So what's left over will be easier. Otherwise, we don't narrow things down to the point where we can kind of finish the problem. So we want to test one, great, we got a yes, then test the other one and see what happens. Now, if this would have been a no, then we would have went back to the original set. But if we're doing one after the other, it's best to go what we call consecutive synthetic. So you get a yes, don't go back to this row, but use this row. So you can see how I've dropped that down. Now, if I solve this factor for x, or I find a potential 0, right? We don't know that it's a 0 yet, that's what we're testing. But I'm going to test it out with synthetic. Again, the first number gets dropped down. And then we go through a series of multiplications and additions. So multiply, then add that column. Then multiply those two, which produces that number, then add that column, then multiply those two, add that column. And it turns out another yes. So really what we've proven so far is that x plus 1 and x minus 1 are actually zeros of the original function, which means they're also solutions, which means they're also factors, right? All those ideas tied in together. And then what about the other factors? Because right, there should be 4 here. We got a degree of 4, highest exponent's 4, so we got 2 zeros, 2 factors. Where are the other 2? That should come from what's left. So when you get this list of terms narrowed down, so we went from 5 terms to 4 to 3. Well, when you get to 3, here's what this actually represents. If you add in exponents and variables, you're there. Now I think about this. This was x to the 4th. And basically we divided out x to the 1st, which means now this is x to the 3rd, x squared, x number. Then we divided out another x to the 1st. So now that means this is x squared, x in number. And then it turns out that thing factors. Now that may not always happen. If it didn't, we'd have to go like quadratic formula, complete the square or something like that, but it did. So there's our other 2. So now as a big picture, we gave you some things to test. So that was kind of a little bit of a like, here you go, hint, hint, right? And we found yeses and yes, and then we completed it by just saying, well, hey, that's actually a 3 term, that's a quadratic, I can just do typical factoring. If I list everything out, it would be everything I figured out. So there's -1, 1, -3, and 2 are actually all zeros of this function. Also, I could write this out as a list of factors. Now too, I'd have x plus 1, x minus 1, x plus 3, x minus 2. So there'd be my 4 factors. So 4 zeros, 4 factors. Right? We can 4 solutions if we set equal to 0 and solve, however you want to wrap it together, but we're going to be kind of focusing on zeros for the most part of this assignment. Okay, let's try a little bit more to see if you guys got the idea of synthetic down. So what if we don't say, hey, test this? You know, you're just on your own. Well, then you got to create a possible list. So the potential list of zeros comes from the lead coefficient and the constant. So lead coefficient would always be the number out front or attached to your largest exponent, but it's this number, your coefficient. Constant is the number term that has no x. So what you literally do is you make a list of all the factors of the constant term over all the factors of the lead coefficient, and then you start testing. Now, we're going to do factoring first because it turns out this does factor, and there are my zeros. So if it would factor, we would never do this. This is a backup to something that can't factor. So we're just going to verify what's going on. Like, yeah, we know the zeros are already this factored. Let's just sort of prove it and show you the method. So here's the potential list, right? I've got the factors of 3, which are 1 and 3, the factors of 2, which are 1 and 2. And then I kind of clean this up a little bit and actually do a list of 1 over 1, 1 over 2, 3 over 1, 3 over 2. So everything over everything. And here's what I'm going to test. Now, if I was doing synthetic, my testing would go like, where do I start from this list? My habit is just start with +1. That doesn't work, then I go to -1, and then I just kind of start working my way through the list. Probably I'll do the whole numbers first, but that's how I test. Now, it turns out, just to kind of match everything up quick, 2, 1, and -3 is right here. 2, 1, -3. I'm just testing 1 as a 0, so I drop it in the upper box here. Bring the first number down, and then I go multiplication, which is that number, addition. Multiplication, addition. And when I get that 0 there, that's a check. Turns out 1 is actually, well, we knew it already was, right? So I'm just kind of verifying it with synthetic. And then if I do that, what's left? Because this was a squared first number. If I just took out a factor of x, then it should be down to x. And there's my other one. So now my list of zeros. Well, again, we already knew that was true by factoring, and we're just kind of verifying with synthetic testing that it is. You would never synthetic test. If it factored, I would always factor first. I wouldn't go, synthetic is extra work. If I don't need to do it, I won't do it, right? And then -3/2. If I set that equal to 0 and solve, I would get -3/2. Okay, let's show you the last one. So again, now a much bigger list, right? Not quadratic and not 4 terms. So I don't really have a good method. 5 terms and have a good method. So I have to start testing. So all the factors of 8 over all the factors of 1 lead coefficient. So 1, 2, 4, and 8 are the factors of 8 over 1. And then I'm again going to get rid of this division, just kind of clean it up. So 1 over 1, 2 over 1, 4 over 1, 8 over 1 is that. And then I'm going to start testing. So I'm just going to start with 1 and just start working my way through the list. Now here I've got 1. You guys can track the work. I'll just kind of walk through it quick. So there's the 0 from the list. I'm going to try. But these numbers here are coming from right here, 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 and here, right? So it's that set of numbers right there that correspond to this set. Bring the first number down. I go multiply. That's the red number. Then I add. Then I multiply and add. And I just keep doing it until I get to the end. Now, the fact that I did not get 0 there means this is not a 0. So guess what? Keep on testing. So I'm going to go to -1. So I'm just going +1, -1, +2. I'm just going to keep going. Hopefully it doesn't take too long to start to find them. And remember, when you do start to find them, then you want to start using the narrowed down list. Don't go back to the original set. So now I'm testing -1 from this list. Same thing. Bring that down and start my rounds of multiplication, which is here. Then add, multiply, which is this number. Then add, and just keep on going to the end. I got a yes. Great. So now what I'm going to do is do another round of synthetic, but I'm going to not use this list. I'm going to use this list because I'm trying to narrow the terms, narrow the terms, narrow the terms. So one more time, I'm going to test 2 now. So I've done +1, -1. Now I'm going to do +2, and I got a yes. So I won't walk us through all the synthetic again. And then what is this? Well, I went from 5 terms to 4 terms to 3 terms to 2 terms, which is actually x squared plus 4. And if I solve it, you know, we know how to do that from that earlier problem in the notes. I get plus and minus 2i. That's fine. Those are still zeros, just not real zeros. So here's all my zeros, and then let's go backwards and turn them into factors. So -1 and 2 by synthetic, plus and minus 2i by solving, and make my list, and then just basically undo it, turn them back into factors, and there you go. So synthetic as a way to find zeros when your original polynomial is not factorable. And it also allows you to find the factors too. That's it for the notes today.